Kia ora Year 12. I was just doing a video for Chinmay from this paper in November 2018, and I found a complex numbers question that I wanted to go over. So this is question 8, and this is just for anyone who wants to watch it. I like it because it's an exponential form question, and we don't see them that often. I also like it because, as usual, if you draw a graph, both of these questions get much easier. So in the first one, it's really clear that we have to show all necessary working, right? And it talks about that in the examiner's report, that you must show how you got to your answers. You're also told that you need to give the values of r and theta in your exponential form correct to 3 significant figures. So just make sure that you follow those instructions. And theta is in radians, not degrees. The second question is a locus question, and it's one where we have to sketch the locus representing that, so that part's really easy. And then we have to find the least value of the modulus of z for points on this locus, and we need to give an exact answer for that one. Okay, so let's take a look at this first one. We've got z, oops, where's my pen gone? So z is equal to 2 plus 3i over 1 minus 2i. Now there are a couple of ways to find the modulus in the argument, but I think the easiest one here is to multiply top and bottom by the conjugate and clean that up first. So here we're going to have in the denominator first, we're going to have 1 minus 2i squared, which gives me 1 plus 4. And in the numerator we get 2 plus 3i plus 4i minus 6, giving me negative 4/5 plus 7/5 I. So nothing particularly lovely. We just need to get on with it and now find r. But before I do that, I'm going to do my sketch. So r is sitting back here like that. Right, now that's probably a good enough sketch to get the correct answers here. Right, so what will r be? Well, we need to take this, square it, and take 7/5 and square it. That gives me the square root. In the numerator, I have the square root of 16 plus 49, which is root 65, divided by 5 and 2. Lots of significant figures, that's 1.6125, but we just want 3 significant figures, so 1.61 to 3 SF. Okay, now let's take a look at theta. So we can see that it's in this quadrant over here. We know that we're going to start off by doing tan inverse of b over a, so 7/5 over negative 4/5. But that answer is going to give me something down here. So we have to add pi on to that number. Now, if you forget to add your pi on and then you take a look at your graph, you'll see straight away that you've screwed it up. So here it's tan inverse of negative 1.75. And that gives me, once I've added on the pi, 2.09 radians. Okay, so the number that you'll get out of your calculator if you just do this bit, I think is... it's about negative 60 degrees, so it's negative 1.05. And they've commented in the examiner report that lots of students made that mistake. So don't let that be you. Just draw a graph and everything will be fine. So my final answer now is that z is equal to 1.61 e to the 2.09i. That's writing in exponential form. Remember, we could write it in polar form as well, but we're not asked for that. Okay, let's look at the second part. We have to do a locus question, and I'm going to try and do that without GeoGebra, but with a ruler. So really useful to have a decent ruler with centimetres on it, and also to take a compass into the exam with you. We can see from looking here that this locus is going to be a circle, and its centre is going to be at 3 minus 2i, and the radius will be 1. Okay, so it's a circle. Centre is 3 minus 2i, and the radius is 1. Remember, if you're doing these for level 3, you need to do them with algebra as well. So let's draw that. It's a simple equality, so nothing too bad. So if we just take the ruler, I'm just going to pause it to do. Okay, so my centre is going to be at 3 negative 2i, so it's down here. And it's got a radius of 1. So let's go up to here, out to about here, out to here, and down to here. And now I'm going to be trying to sketch a freehand circle. Wow, the magic of OneNote, right? So that's made it into a beautiful circle. Now that's going to help me because what I'm looking for now, so that's my locus, right? So let's write that on. So that's z minus 3 minus 2i equals 1. And now I need to find the place on that locus which is the least, has the least modulus, right? But it's got to be on that locus. So here's the way we think about it, and this is what I'd write down. So anywhere on the locus is the same distance from the center. So it's 1 unit from the center. The center is the point that we know really easily in there. It's at 3 minus 2i. So anywhere on the locus is 1 unit from 3 minus 2i. So we're going to find for the modulus the place, the shortest distance from the origin to the center, and then we're going to take off 1 unit because we know that that's going to work. Okay, so what's the shortest distance from the origin to get to the center? Well, the shortest distance between 2 points is a straight line. So all we got to do is this. We have to find this distance here. Whoosh, should have done that in a different color. We're going to find that length, and then we're going to say, well, that whole length is something, and then we don't have to go all the way. We just have to go to there. Right, so the distance from 0 to point A, so 0A, is equal to 3 squared plus negative 2 squared, which is the square root of 13. So we know that AB is 1. So OB is equal to root 13 minus 1. And that's my final answer. Okay, so that's the shortest distance. That's the minimum modulus point on the locus. So we haven't found the coordinates of that point B. We weren't asked to do that, right? So we just had to find the least value of this thing here. All right, thanks for watching. Please keep on sending in any questions that you'd like me to go over.